Hello and welcome to Quadrific. In this video, we are going to see using GridSearchCV how we can tune hyperparameters for classification on MNIST Dataset. This video belongs to part 1 in which we saw how we can get good performance over label predictions when we switch over network from regression to classification. So 99% of the code I have taken from that video. I recommend you to watch that video before continue watching this video. So I'm back to my Spyder editor of Python, and as I told you before that 99% of the code I have taken from the part 1 of the video, and I have added a link in my description box. In this video we are going to learn how we can tune hyperparameters or how we can search for perfect setting of parameters, getting the highest performance on using GridSearchCV function of Python. In what scenario we can tune hyperparameters? For example, in this model we have classified the MNIST dataset to predict the one-hot encoded labels, and for training the model we used batch size 128, a random guess, and we used shuffle true. If we don't know or we are not sure if we keep the shuffle false, will we still get the good performance by the trained model? Another thing is that we are not sure that if we change the optimizer to SGD, will the mod still work or no. So in such a scenario where we are confused with respect to different set of parameters, we can use GridSearchCV as a miracle tool. So let's begin how we can do that. As I told you before that I'm going to use a function GridSearchCV, and to use this function I have imported sklearn.model_selection library. First I'm going to create a function which will enclose the model that I have defined in part 1, starting from input layer to compilation of the model. Now you can see that I have created a function which encloses all of the layers starting from input to compilation of the model, and at the end the function will return the compiled model. So here in the pre-processing block I have kept the lines of code same. I have changed nothing, so I am going to remove this part and everything else. To use the grid search, first we need to initialize set of parameters that we want to do our search on. For this task I have used 3 parameters: batch size, shuffle and optimizer. Remember that these are the parameters that we used in model.fit function. It is necessary to use the same name of variables that we use in model.fit. For optimizer I am going to do a grid search on SGD and Atom optimizers, and I want to check what happens if the performance increases or decreases while keeping the shuffle true or false. And the batch sizes I have used 2 for now. You can use as many batch sizes as you want to do a grid search on. Next I'm going to create a model. We can perform grid search. Either we can use Keras classifier or regressor. Here, as we know that the model is trained as a classifier, I have used Keras regressor. I know it is not a regression task that our model does, but if I use Keras classifier, it will generate an error. It will not stop the training, it will keep doing the grid search. But if you do classification on Keras regressor, you will not get any error. So using the Keras regressor on a model that does classification will not affect the performance of final prediction. So Keras regressor takes parameter the function where it generates a compiled model. So here I have already created a function which is generate_classification_model that generates a compiled model, and to see the progress I have kept the variables on by passing the value 1. And to use Keras regressor, I have imported keras.wrappers.scikit_learn library. I have generated my model. Next, I am going to create a dictionary with all of the parameters that I am going to use for a grid search. As you can see inside the dictionary, I have placed all of the parameters: batch size, shuffle and optimizer, and its values are the same as the name of variables. Next, I'm going to call a GridSearchCV based on my model and the dictionary. It will generate a compiled model that I will fit later. The first parameter that GridSearchCV takes is the estimator, and as an estimator I have passed my generated compiled model. The next parameter, it takes the parameter grid that I have created as a dictionary right above this line. Next, I'm going to fit the grid on my input dataset, which are x underscore train and y underscore train. Besides that, I want to see how much time it took for doing a grid search on my input dataset. To do that, I have started my clock, and right after it finishes doing the grid search, I am going to take the difference between the time when I started the clock minus the current time. By doing this, I can know that with these sets of parameters, how much time it takes to do a grid search on my input dataset. After the grid finishes the grid search, total history of search will be passed to CLF variable, which will tell us the best score and the best parameter. And to print that history, we are going to print clf dot best underscore score underscore and the clf best underscore params underscore. So this will print the parameters on which it obtained the best score. Let's run the model. So while the network trains for best parameters, I want to take the advantage of this time. As you can see that I am going to pass the optimizer through grid search using the parameter optimizer, in which I have used two elements for SGD and ADAM respectively. And as you can see that the model I have enclosed inside a user-defined function. You can see that I have passed the optimizer as a default parameter. In case if I don't tune it or remove it from grid search, it will use the default settings, which is Adam. But in case if I pass another value for optimizer, it will be replaced by this initialized value. And here you can see in my model compile, I have not used any direct value. Instead, I have passed the optimizer variable through grid search. If you want, you can also tune other parameters for training optimization. For example, you can use learning rate by defining it with the same name as the same name of parameter that we use in model.fit. And similarly, you can pass that learning rate with comma learning rate. Even if you don't use learning rate here, because I have enclosed this user-defined function only up to compile, but automatically the grid search will pass the learning rate that we define through our grid search. It will automatically be conveyed to the model.fit computation. And if you notice that I have not saved the trained model, this is only the grid search in which I will get only the best parameters based on the best performance. So using those parameters, I can again train my model and save the best model according to the parameter that I specify in training. This is it for this video. Thank you for watching. I hope you find it helpful. If you did, do like and share. Also subscribe the channel and hit the bell icon so that you get notified whenever I upload a new video. If you have any suggestions, leave them in comments section. I will do consider it. Thank you.